Hi, everyone. Thanks for tuning into Stacker Chats. I'm Gina Abrams, and I'm joined by Muneeb, Stacks founder. Stacks is a Bitcoin L2, and in these chats, we connect on recent happenings on Bitcoin and Bitcoin layers. So, Muneeb, last chat, we spoke about Bitcoin L2s, and this week I wanted to ask about specifically the path for innovation on Bitcoin like rollups. So what does the path look like for ZK syncs and other innovation on Bitcoin?
Yeah, I think that's a great question. So I'll first give a little bit of the historic background around this. So I think I've mentioned on these chats before that I think 2017 was a pretty critical year where, given the sort of like traffic that we saw on Bitcoin L1, but also it was kind of like the first year where Ethereum saw like a lot of traffic with CryptoKitties and lots of ICOs and whatnot. It basically became very clear, both in the Bitcoin camp and in the Ethereum camp, that the future of scalability is mostly layers. Like that's when the Stacks project really started late 2014 when we raised the first round of capital for it, and Lightning Labs started like around that time, and so on, right? Same on Ethereum. Although on the Ethereum side, I think there were two camps. One were trying to scale the L1 through ideas like sharding, and a bunch of things, and the other camp was like, hey, let's try to build layers, and then there are different types of layers, and we can sort of like get into that. I actually have a pretty interesting blog post from that time, like maybe late 2016, early 2017, that sort of says that the L1 scaling solutions are very complex and likely not going to work, and we should focus more on the L2s. And 5 years later, it's a little bit like, even talking to some of the Ethereum people, they're like, yeah, the sharding stuff is out of the window now. Most of the effort is now spent on L2s, right? Which sort of makes sense. I think Solana is actually the example that those people are still focused on scaling just one L2, and obviously it comes with trade-offs like centralization and whatnot. But I think they're doing a great job exploring it. But in general, I think it's safe to say most of the industry is converging on L2s, at least on the Ethereum side, very clearly that L2s are going to be the path forward, right? There are so many projects on Ethereum. So these could be fraud-proof systems like Arbitrum, or other ZK rollups like ZK Sync. And I think we can get into the differences maybe later on. But at a high level, I think the idea is that in a rollup, things can be more private, things can be more scalable, things can be cheaper, and then you sort of like use the L1 for validating the state of the rollup, right? So the L1 chain actually becomes more like a verifier, right? So if it is basically it's not actually taking the bulk of the load, and you're not doing the transactions there, and these things can be compressed pretty significantly. So the state that ends up on the L1 could be pretty small, and so in a rollup, the act of actually producing the proof is the computationally intensive part. Verifying it is relatively simple, right? So think of it in a way that, imagine, this is a rough analogy, that it takes like a heavy-duty data center computer to actually produce the proof, but you could just quickly verify it on your cell phone, right? So it's some analogy like that the L1 computational requirements aren't actually that high. The bulk of the load is actually done on the production side, on the roll. And that model, interestingly, is pretty similar to how the Bitcoin philosophy works, right? The L1 can be very, very simple. And I think you don't need a lot of complexity at the L1 level, and you can potentially have just very targeted opcodes. So Bitcoin has a very simple scripting language, Bitcoin script. Think of that as almost like a calculator, right? Like, hey, you can add things and you can do very basic stuff, but it's not a general purpose computer like Ethereum Solidity languages, or even Clarity on the Stacks L2 side. But you can add like very specific opcodes. Think of opcodes as like very targeted sets of instructions, like an addition in a calculator, right? Like it's a very specific thing. So you add that to Bitcoin, where Bitcoin L1 can actually verify some of the rollups, right? So there are Starks and Snarks, like there are some differences there, but without getting into the technical details, a op Stark verify or a op Snark verify opcode can do the trick, right? Which is really interesting news. So let's say Bitcoin can do that, and we know Bitcoin usually it's like very hard to make changes to Bitcoin, and it has a very high bar for, hey, are we going to break something and then whatnot? So obviously a ton of work would need to be done for even a change like that. But let's assume Bitcoin makes that change. What does the world look like at that point? At that point, what the world looks like is you have Ethereum that has a full execution environment on the L1, and it has the capability for verifying the rollups because it has the full execution environment. It's like a superset, right? It can do anything. So it can also verify the rollups. Bitcoin is much more simple. You can just transfer your UTXOs, do like a bunch of like basic things, but in a very targeted way, you can also verify the rollups. And at this point, on the Ethereum side, most of the applications, like this is years down the road, are running in L2s anyway, right? So it's a little bit of a question mark that, hey, what is then happening at the L1? Because if bulk of the applications are running on L2 anyway, and they're rollups or some other kind of like remix of that. And at that point, I think if you squint your eyes, the scaling capability, but also the capability to program either BTC or Ethereum in a rollup actually starts to look like very, very similar, right? And I think that's a very exciting thing, especially for Bitcoin, because Ethereum right now is much further advanced and mature in terms of the type of applications that are being built, the type of use cases for ETH capital. I think for BTC to win as capital, it needs to have like a ton of use cases. I think holding in cold storage is a great use case, like it's a store of value, but I think it needs to have online digital use cases in an open financial system, a circular economy, both digital and in the real world. And I think a lot can be done. And this is obviously the work that we're trying to push forward. So what does that mean for the stacks layer? What does that mean for things like SBDC? So with that model in mind, let's basically come to SBDC first, right? So let's say we have this basic understanding that Bitcoin can in some ways rival Ethereum in a couple of years if we can get the codes, because at that point even the Ethereum believers wouldn't be able to point to anything and say like, oh, it's not secured by Bitcoin L1 or something. Like I think that at that point there's basically no difference, right? So what's the next theoretical best thing you can do if you think it's like 4 or 5 years out that Bitcoin gets these opcodes? So the next theoretical best thing is that you can move your BTC out of L1. You can take it from L1 to L2, because that actually requires the L2 like stacks to be aware of the L1, which is easy to do, right? All these L1s the stacks already watches all of the state of Bitcoin L1. So that's the easy part, that movement of BTC from L1 to L2. The hard part is taking it from L2 to L1, because Bitcoin L1 has no idea that the L2 even exists, right? So it doesn't even know that this thing is there, and it's not going to like verify anything and do anything for you. And that's why we need the opcodes, so that it knows that something exists and it can actually verify those proofs or bring the Bitcoin back and so on. So if you can't do that, right? So that's the critical link. That's where SBDC comes in, where it says, well, how about a decentralized group of signers that have economic incentives to sign a transaction and bring the Bitcoin back? Which, if you look at the general architecture, I know SBDC has a very specific architecture where people are locking capital in the stack's consensus. There are BTC rewards that they're getting as incentives, but stepping a little bit like high level, generally speaking, having a decentralized group of signers to do that step is the theoretical best thing you can do, right? Like there's basically nothing else. Otherwise, you just have to go and change Bitcoin itself, right? So SBDC sort of like becomes the theoretical best thing, because what's happening is that this layer, the stacks L2, is giving the most importance to this function, right? Because it is the consensus level. this signing process is basically embedded at and secured at the consensus level, meaning that if something goes wrong with this signing of bringing Bitcoin back, the stacks layer consensus would just halt, right? And that's in any blockchain, like that's the strongest level of security that you can guarantee that, look, the entire economy of this thing is just going to halt if something goes wrong with the signing process. Is that important, right? And again, no other ecosystem is doing that. There are different types of bridges of bringing BTC from one layer to another. They're all done at the application layer. They're not done at the consensus layer, where you're saying that, hey, this is the most important thing, and then all of the capital, like depending on the price, I know it keeps going up and down. There's roughly $400–500 million locked in consensus even right now, right? And this could be more as the ecosystem grows and more attention comes to Bitcoin L2s and so on. So the economic guarantee is not nothing, right? Like obviously we want, like, you know, tens of billions of dollars of Bitcoin to come in, and there are ways to sort of like get there. But this is a great start, right? Like there's capital locked. There is already a decentralized group of signers, given we had such a wide distribution of the asset at the start of the project. If people remember, during the SEC qualified offering, there were more than 4,500 independent entities and individuals who participated. And hopefully that number has since only grown more, right? Like there were more people who have sort of like joined the ecosystem. There's such a strong emphasis on decentralization in this ecosystem as well. There's so many independent entities. There can be many independent signers who are custodians and so on. And I do think like it's sort of like how important this function is for the stacks L2, that the signing process could be very decentralized. And I think that's great, because from a commercial perspective, this can work really well until you're looking at integrating rollups. So interestingly, when you talk about rollups on Bitcoin, there are some newer projects that are coming up as well. And at a high level, you can sort of like divide them into two categories. One of them are effectively what's called sovereign rollups. These don't require any change from Bitcoin L1. What they're really doing is they're just embedding all of that data. You can think of a rollup as almost like a layer, like a L2, or almost like a blockchain even. They're just embedding all of the data in Bitcoin, or at least are proposing to. These things are not live yet. But once you embed all of the data in Bitcoin, Bitcoin is not verifying anything, right? Like you can't take your BTC out of a rollup and verify it at the L1, but your data is actually secured by Bitcoin, which is an interesting property. People call it data availability, or DA. So data availability becomes a Bitcoin guarantee. That it's sort of like ordinals, right? Like when you put your JPEG in the Bitcoin chain, it's sort of like now there, right? And it's indestructible. So similarly, these rollups, their data becomes like indestructible. And I think it's an interesting and great property to have. And the second thing is that they have reorg resistant property of the Bitcoin L1. For someone to come in and say that, hey, these transactions didn't happen, let's try to reorg, they would have to go and reorg Bitcoin. Interestingly, with the Nakamoto release, the stacks layer actually starts looking closer to a sovereign rollup-like system. It does not have the data availability, not full data availability, because stacks has much more data. It's not compressing things like how these ZK proofs compress data. So we're not putting all of that data into Bitcoin. Like that would just flood the chain or be much more than what the Bitcoin data is. But we are putting the hashes in the chain. So you can verify that this is the right data, right? Just by looking at the Bitcoin chain. And in Nakamoto, the current proposal is to follow Bitcoin finality, just like these sovereign rollups would follow Bitcoin finality, meaning that to change something, to change the history, you'll have to go and fork Bitcoin. So I think basically after Nakamoto release, stacks like becomes closer to what sovereign rollup, the direction that sovereign rollups are sort of like going in. And as various entities in the ecosystem, they start doing more research on rollups. Like I can speak for my entity at Trust Machine. We definitely are thinking of booting up some efforts for doing initial R&D. Like these things are still off, right? Like other than the changes required to Bitcoin, there are just R&D work needed on rollups in general to make them very practical and scalable so that everyday users can use it. These are still very expensive, and there are many corner cases that sort of like need to be figured out. So what does the roadmap, at least in my mind, looks like? Again, this is a very decentralized ecosystem. The ecosystem will figure out organically what the roadmap is, but at least in my mind, in the time between the Nakamoto release and when Bitcoin gets the opcodes, you have SBDC, which is the theoretical best thing you could do for moving Bitcoin capital into a layer back in a decentralized way through the signers. And then with the Nakamoto release, consensus changes, Stacks starts looking closer to like a sovereign rollup, which is sort of like the only type you can have right now until Bitcoin has the opcodes. And as we start getting closer to Bitcoin having the opcodes, you can absolutely integrate them to improve the security of SBDC, because rollups will need assets like SBDC, right? Whenever you're moving your BDC from L1 into a rollup, it is something else. The security is not exactly the same as Bitcoin L1. And you're effectively moving it into a layer and then back, right? So SBDC is that asset that you're moving from L1 to L2, and it's just the security properties that it can shift in the future from the decentralized group of signers, which in my view is actually secure enough if the group is decentralized enough and they have enough capital locked and skin in the game. But with the opcodes, you can actually like upgrade that security. So when they come online, like my hope would be that the developers in the Stack ecosystems would sort of like jump on that opportunity and they would upgrade the security of SBDC. And I think that's where I see sort of like Stacks going in the future.
Excellent. Thank you so much for that overview. And so we were talking about how these changes are probably going to take time. Can you share a little bit more about what does this sort of, what's the path forward for some of these updates? How does like Bitcoin governance work? If you could share a little bit more information on that path forward.
Yeah, so I think Bitcoin governance is actually pretty interesting. You would think that, hey, it's a decentralized thing and developers can propose changes and there's some sort of a governing body. It's actually pretty ad hoc in my experience, right? Like basically there are two categories. One category is that there are a group of developers or basically individuals who have a history with Bitcoin, and they're sort of like well respected in the Bitcoin core dev circles. And it's a pretty small circle. Like it's not a very big circle. It's a bunch of like ex-Blockstream engineers, or it's people like Adam Back, who's sort of like obviously referenced in the Satoshi paper itself. And so there it's sort of like it's a smaller group of people, and proposals coming from those people actually have a much easier time getting through. It's just a fact, right? Like, I mean, people can debate it. No, those proposals are good, this and that, but it is something that I've just witnessed directly, and other people have witnessed as well, that interestingly, a lot of people in the Bitcoin community are actually not very technical, right? Like on a relative basis. And like in Ethereum, there are a lot more developers and engineers, even in other ecosystems. A lot of people in Bitcoin are actually not technical, and they look at very few people for understanding technical things, right? They will look at maybe Jameson Lopp or Adam Back or some core developer, and they will be like, hey, I don't understand this. What do you think about it? So what do these people think about the proposals actually matters a lot in Bitcoin. And repeatedly, we've seen that if there's some proposal that comes outside of these small circles, that's going to have a much, much harder time getting through, right? So we've seen what happened with Jeremy Rubin's proposals, and there's a history of it, right? Like we can go there. So for me, like for something like this, which is going to be a big change in Bitcoin, like I wouldn't even try to propose anything, frankly, right? I would actually try to just slowly get buy-in from a lot of these relevant parties. And I think the reason I am confident that these changes can actually happen is that at least I'm seeing early signs that there is a lot of demand for these opcodes from various circles, from Lightning developers, from even people at companies, I don't want to name them, but who are generally resistant to change. They're kind of like saying, that might be interesting actually, right? So I'm hopeful, but the way I think if you're a young entrepreneur and you want to like really want these opcodes, I don't think the first step is going to be that you write a BIP and sort of like publish it. I think I would highly recommend people to do a lot of in-person talking, get feedback. Don't try to act like you know everything, right? Like this, there's a well-established history of how things work in Bitcoin, and you would have to kind of like get in front of those people, get early feedback from them, try to get buy-in, and you'll start getting early indications. Like, are you getting that support? Are you not getting that support? If you are getting that support, I think you can start to build momentum, write up a Bitcoin improvement proposal, and slowly sort of like, get the community behind, because I do think Bitcoin community is very, very vocal, and rightly so. And they do run independent nodes, and they do exercise their right to do user activated soft forks. So it's not gonna, I think a lot of different parties will have to come together. It's just not just the miners. Miners are actually pretty kind of like low on the list of things. If you can get a lot of, let's call them technical leads and respected figures behind you, if you can get the core developers behind you, and then if you can get the community behind you, I think exchanges and miners, they are actually relatively easy. Miners sort of like follow the price, and the price is determined by which version of Bitcoin is supported on exchanges and by the users, right? So that's at least in my mind, that's how the hierarchy of things work.
All right. Well, thank you so much for this. And thanks to everyone tuning in. Please make sure to like this video, make sure you're subscribed for more content like this. And if you have questions, either reach out on Twitter or in the comments below. And thanks, Muneeb. We'll see you next time.